Okay, I think I'll get started now. So, hi, I'm gonna be live solving the SMC 2020 paper now, and I haven't seen the marking for this paper in a long time, so it should be fully authentic. I just want to check that you can see my pen strokes now. Type yes into the no mic channel. Okay, cool. So before I get started, I just want to talk about what the SMC is and how the scoring works. So the SMC is a challenge run by UKMT, which is targeted at year 13s and below. And the way it works is it's a multiple choice exam where each question has 5 options. The questions will get harder throughout the paper. And the way that it's scored is you start with 25 points. For every question you get right, you gain 4 points. If you leave a question blank, your points don't change. And if you get a question wrong, you lose 1 point. So the overall exam is out of 125. In terms of timing, it's 1.5 hours, and the knowledge you'll require to solve the SMC paper will be around GCSE level knowledge, but it will be applied in a way that is not as obvious as a typical GCSE question. There are some A-level concepts that you might want to know, but typically you won't need these. Also, you will not have to prove anything on this exam. It's answers only. So you can use that to your advantage when you're solving certain questions that you might not be fully sure about. And the last thing is, what equipment can you use during the exam? Well, it's non-calculator, and you're not allowed measuring instruments. So that includes protractors and rulers, but I believe you are allowed a compass. So that's all the information about the exam. So I think I can get started with actually answering the first questions. Question number 1, what is the value of 2020 over 20 multiplied by 20? Well, I'm going to notice that 2020 itself is divisible by 20, and in fact, 2020 is equal to 101 times by 20. So this is equal to 101 divided by 20, which is 10.1 divided by 2, which is 5.05. So the answer is D. What is the remainder when 1,234 multiplied by 5,678 is divided by 5? Well, divisibility by 5 is only dependent on the last digit. So you might be familiar with the fact that a number is divisible by 5 if it ends in a 0 or a 5. And the way we can work out the last digit of this product is just finding 4 multiplied by 8, which is 32. So the last digit will be 2. And that means that this will be 2 more than a multiple of 5, so the remainder is 2, which is C. Can you hear my laptop fans? Okay, phew. A shape is made of 5 unit cubes as shown. What is the surface area of the shape? So the first thing is, what is a unit cube? A unit cube is a cube where the side lengths are all 1 unit. So the area of each face of a cube will be 1 squared, which is 1. And now we have to try and count how many faces are exposed in this shape. So for 4 of the cubes, this cube, this cube, this cube, and this cube, 5 of the faces are exposed. So 5 times 4 is 20. And then for the inner cube, only 2 of the faces are exposed. So 2, and that means that the answer is 22. So A. Okay, numbers p, q, r, and s satisfy the equations that p equals 2, p multiplied by q is 20, p multiplied by q multiplied by r is 202, and p times q times r times s is 2020. So we want to find the sum of p, q, r, and s. So the way we can find the value of each of the variables is we can notice that if we take one of the equations and then divide it by the previous equation, like for example, if we have p times by q divided by p, that leaves us with just q. So that means that q is equal to 20 divided by 2, which is 10. In a similar way, we can say that r is equal to 202 divided by 20, which is 10.1. And the last thing is s is equal to 2020 divided by 202, which is 10. So that means that p plus q plus r plus s is 2 plus 10 plus 10.1 plus 10, which is 32.1. So the answer is B. Okay, what is the value of the square root of that number? So I think this question is the first question where it might not be immediately obvious how you would answer such a question. So I think one way you could approach it would be if you're familiar with the following identity, which is 1 plus x squared plus all the way up to x to the power of n, all squared. This is equal to 1 plus 2x plus 3x squared plus all the way up until n times by x to the power of n. And then the coefficients of all the subsequent terms are decreasing. So it would be n minus 1 times by x to the power of n plus 1. And this would go all the way up until 1 times by x to the power of 2n. And if you're familiar with that factorization, then you'll be able to substitute in x equals 10 and n equals 5 to get that the answer is C with 5 digits. But if you're not familiar with that factorization, this is quite a bit harder. But because you might think that the only way to solve the problem is to actually square each number and see what you get. And you might be able to spot the pattern that the digits are increasing up until the maximum and then decreasing, but that would be time consuming. So the one thing you might spot is you might want to count the number of digits. So if I count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 digits. So if we have 9 digits and if we square a 3-digit number, we're never going to get a 9-digit number. If we square a 4-digit number, we're also never going to get a 9-digit number. And then if we square a 6-digit number, then there'll be at least, well, a 6-digit number will be greater than 10 to the power of 5. So if we square both sides, that means that x squared will have more than 9 digits. And similarly, if we have a 7-digit number, it's also going to have more than 9 digits. So that just leaves C as an option. So that would be a method that you could use with if you're not sure what to do, or if you haven't seen a problem like this before. So question number 6. There are fewer than 30 students in the A-level mathematics class. 1/2 of them play piano, 1/4 of them play hockey, and 1/7 of them are in the school play. How many of the students play hockey? So So if we have X students in the class and a quarter of them play hockey and a seventh of them play in the school play, then we know that X is both divisible by 4 and X is also divisible by 7. Otherwise, those numbers would not be integers. And the smallest number, which is both divisible by 4 and divisible by 7, is 28. So this means that if we find a quarter of 28, we'll get 7. Official UK accident statistics show that there were 225 accidents involving teapots in 1 year. However, in the following year, there were 47 such accidents. What was the approximate percentage reduction in recorded accidents involving teapots from the first to the second year? So this one, well, we're looking at the reduction. So we want to find the difference between the first and the second year, and that would be minus 47. But if we're trying to approximate, so we could approximate this to something like 225 minus 50, which is 175, and then this is as a percentage of the initial accidents in the first year. This is, we could calculate it, but I think it should be around 80%, because if it was 90%, then 10% of 225 is 22.5. So that would mean that the numerator would be around 200. So I'm going to go with 80%. Now this one, what is the largest prime factor of 106 squared minus 15 squared? So you should be able to recognize that this is a difference of two squares, which is, I think difference of two squares comes up basically every year. So it's a good one to remember and a good pattern to try and recognize. So 106 plus 15, 106 minus 15. And that is equal to 121 multiplied by 91. And that is equal to 11 squared multiplied by, I think that is 13 times 7. I'm just going to check that is 91 is 13 times 7. Yeah, okay. 13 times 7. Now we have the prime factorization of that number, and the largest prime factor is therefore 13. In 2018, a racing driver was allowed to use the drag reduction system provided that the car was within 1 second of the car ahead. Suppose that two cars were 1 second apart, each traveling at 180 kilometers an hour in the same direction. How many meters apart were they? So this is kind of like a physics type question. So the question, if I draw the cars as circles, and then this distance in between them is what we're trying to find. So, well, I'm gonna use the physics equation that distance is equal to speed times time. We know that the time is 1 and the speed is in kilometers. I think we have to convert the units for either speed or time. So I'm going to convert the units for speed into meters per second. So we have 180 kilometers an hour, and that is equal to 180 divided by 3,600 kilometers per second, and that is 1/20. Correct me if I've made any mistakes anywhere. And then to convert to meters per second, that would be multiplying by 1,000. So and that is 50 meters per second, which seems reasonable. So we can substitute in 50 here to get that the distance between them is 50, which is B. 6 friends, Pat, Cosima, Roman, Sam, Tara, and Yuma, stand in line for a photograph. There are 3 people standing between Pat and Kasim. So if I denote each person by the first letter of their name, we have P, U, R, S, T, and U. So we have Pat and then Kasima somewhere, and we know there are 3 people in between them. Are you allowed extra paper in the exam? Not squared. Yes, you're allowed as much paper as you want for rough notes. So 3 people in between P and Q. There are 2 people in between Q and R. So that means that R can be in 2 places. Either R is here or R is here. But if we look at this case, this would imply that there's 1, 2, 3, 4, 5, 6, 7, 8 people in total. So that cannot be true. So therefore, R is there. And then there's 1 person between Roman and Sam. And we know that it says that Sam is not at either end of the line. So that rules out that Sam cannot be here. So therefore, Sam is there. And then the last person who you've not put down is Yuma. You, right there. How many people are there standing between Tara and Yuma? Oh wait, we need to put Tara down as well. This means that Tara is, oh, I see. So Tara can be at either end of the line, but in either case, there'll always be 2 people in between Tara and Yuma. So the answer is 2. If I'm going too fast, someone tell me. I mean, I was trying to go through the first 10 questions a bit more quickly, so we could have some more time for the later ones. Okay, cool. What did I get on the SMC last year? I got 24 out of 25. I got the last question wrong. Thank you. Am I applying to Cambridge? I'm not sure. I mean, I have until next year to decide, but yeah. I probably would apply to Cambridge. I would apply to Cambridge or Oxford. I'm not sure which of the two yet, but yeah. Okay. Question 11. Two congruent pentagons are each formed by removing a right angle isosceles triangle from a square of side length 1. The two pentagons are then fitted together as shown. What is the length of the perimeter of the octagon that is formed? So it's saying that if I draw this line, then this isosceles triangle has been removed, and the square has a side length of 1. So if this has a side length of x, then we can use Pythagoras to have x squared plus x squared is equal to 1. X squared is therefore equal to a half, and therefore x is 1 over root 2. Now we're looking for the perimeter, so I'm going to label the lengths of every side that is on the perimeter. So this has a length of 1, this side has a length of 1, this side has a length of 1, this side has a length of 1. Now this bit here has a length of 1 over root 2, so therefore this length here is 1 minus 1 over root 2. And similarly, this bit is also 1 minus 1 over root 2. And this side length is 1 over root 2. This side length is 1 over root 2. So if I go and add all these sides together, we'll have 1, I'll cross them off as I go, plus 1 minus 1 over root 2, plus 1, plus 1, plus 1, plus 1 minus 1 over root 2, plus 1 over root 2 plus 1 over root 2. And those are all the sides. And then I'm going to notice that this minus root 2 will cancel with this plus, this minus 1 over root 2 will cancel with that plus 1 over root 2. This minus 1 over root 2 will cancel with this plus 1 over root 2. And that just leaves 4. Sorry, not 4, 6. Because 1, 2, 3, 4, 5, 6. Yeah, 6. A three-piece suit consists of a jacket, a pair of trousers, and a waistcoat. 2 jackets and 3 pairs of trousers cost £380. A pair of trousers costs the same as 2 waistcoats. What is the cost of a three-piece suit? So I'm going to write each cost out algebraically. So I'm going to let jackets equal J pounds, trousers T pounds, and then a waistcoat W pounds. And then I'm going to write as equations the information that's given. So that is 2 jackets plus 3 pairs of trousers is 380. And a pair of trousers is the same as 2 waistcoats. And the question is asking for the cost of a three-piece suit. So the question is asking for a jacket plus a waistcoat plus trousers. So, and we can substitute in that trousers are equal to twice the cost of a waistcoat. And that gives J plus 3W. Well, actually, I don't think that's the best way of doing it. I think what I'm going to do is I'm going to rearrange this to be T over 2 is equal to W, and then substitute it in here. So J plus T over 2 plus T, and that is equal to a half of 2J plus 3T, and we know the value of that, which is given here. So that is equal to a half sorry, a half of 380, which is 190. Oh yeah, I will apply to Cambridge or Oxford. I'm just not sure which of the two I'll apply to. So, question 13. The number 16 factorial divided by 2 to the power of k is an odd integer. And just in case you're not familiar with factorial notation, it gives it here. It gives that n factorial is equal to 1 times 2 times 3, all the way up until n. And it's asking for the value of k. So we have that 16 factorial is equal to 1 times 2 times 3, all the way up until 16. So, and we're given that when you divide it by some power of 2, we get an odd integer. So one way of approaching this would be to see what the highest power of 2, which divides 16 factorial, what is that number? So the only numbers which are going to be contributing factors, which are powers of 2, are even numbers. So I'm going to list out all the even numbers from 2 to 16. Okay, and now I'm going to list the highest power of 2, which divides all of these even numbers. So this is 2 to the power of 1, this is 2 squared, this is 2 to the power of 1, this is 2 cubed, this is again 2 to the power of 1, this is 2 squared, 2 to the power of 1, and then 2 to the power of 4. So therefore the highest power of 2, which divides 16 factorial, is their product. And that is 2 to the power of, if I put these two together, 2 cubed, times by 2 to the 4, times by 2 cubed, times by 2 to the 5, and that is 2 to the 15, I think. So my answer for the value of k will be 15. And the reason is, if we divide 16 factorial by 2 to the power of 15, we'll have no more even factors left, so we'll be left with an odd number, which is what the question is said. Diane has 5 identical blue discs, 2 identical red discs, one yellow and one yellow disc. She wants to place them on the grid opposite so that each cell contains exactly one disc. The 2 red discs are not allowed to be placed in cells that share a common edge. How many different looking complete grids can she produce? So the first thing I want to do is decipher what it means by different looking. And the way I'm going to interpret that is, if we can rotate a grid to produce the same grid, I think those will still be considered different. So they've given a requirement about the red discs. So the first thing I'm going to do is see where can I place the red discs. So if I have a red disc in this cell, that means that this cell and this cell are out of bounds. So we only have 5 more choices for the remaining red discs. And I'm going to go through like that to try and work out what are the possible places where the pair of red discs can go. So with this, I have to make sure I'm not over counting, because if I place a red disc here and then let's say a red disc here, and then I come back and I place a red disc here and then a red disc here, those two are still considered to be the same thing. So one way I can avoid this overcounting is I can initially overcount, and then the number I get I can divide by 2. So because the number of times I've overcounted is exactly 2 times for each pairing, because in a pair of numbers there are 2 numbers. So I'm gonna go just case by case. We already did this, and we saw there was 5 choices for the other red disk. Now the next case is where we have a red disk here, cross these ones out, and there's again 5 choices. And there's a kind of symmetry to this problem where if you put a red disk in any of the corners, then there will always be 5 other places for the other red disk. So this corner and this corner will again contribute 5 more. And then if there was a red disk here, then we can't put the other red disk in any of those 3 squares, which leaves 4. And again, I'm going to apply the symmetry for all 4 of the squares in the middle of the grid. And then this is equal to 20 plus 16, which is 36. And then the last step would be to divide by 2, because I've overcounted by exactly a factor of 2. So that gives us the number of ways that the red disks can be placed. And now there's 5 blue disks and 1 yellow disk left over. We know that there are, if we've placed 2 of our red disks down, then there's 6 remaining squares. So once we place down the yellow disk in any of those 6 spots, the remaining 5 places must contain blue disks. So all we have to do is take our 18 and multiply it by 6. Can I explain why we divide by 2? So basically, what I've done is what's happening is in the way that I've counted the case where we choose a red disk first in one spot and then the second red disk in another spot. And then I've also counted where we first put the red disk in the other spot and then place the second red disk in that initial spot. I've counted those twice. So to get rid of counting them twice, I need to divide by 2. Does that make sense? Okay, for multiplying by 6, let's imagine that the red disks were here. We have 1, 2, 3, 4, 5, 6 locations where the yellow disk can go, which is why I multiplied by 6. And then we know that all the remaining squares must be filled by blue disks, so we don't even have to consider the blue disks, because there's only one way that we can place the blue disks on the grid. Does that make sense? Okay. 18 multiplied by 6 is 108. So I'm going to go with 108 as the answer. Okay, the shaded area in the diagram consists of an interior circle of radius 3, together with the area between the circle and the 2 tangents to the circle. The angle between the tangents at the point where they meet is 60 degrees. So the first thing I'm going to do is I'm going to recall I don't know if this is officially a GCSE circle theorem, but it's the fact that when 2 tangents meet, the lengths of those tangents will be equal. So this will be equal to this side. And then what I'm going to do is I'm going to draw this line here. And because this is an isosceles triangle, but one of the angles is 60, therefore all of the angles, because all the angles add up to 180, and if this angle is x and this angle is x, then we get that x plus 60 is 180, and therefore 2x is 120, and therefore x is also 60. So this triangle is in fact an equilateral triangle, which will be useful. Oh, it's not working. Okay, so what I'm going to do is we're trying to find out the shaded area. So the first thing I'm going to do is I want to split this shaded area into 3 regions, which I'm going to label A, B, and C. So the first thing is we're trying to find out the value of A plus B plus C, and we'll notice that the area of the circle is equal to A plus B, and then the area of the equilateral triangle is equal to B plus C. And we know how to work out the area of a circle. It's just pi times by r squared, and it tells us that the radius is 3, so that would be 9 pi. And then the area of the triangle, I'm going to use the first thing we're going to have to do is work out what the side length of the triangle is. So I'm going to just quickly rub out one of the labels, and I'm going to draw on the center of the circle, and I'm going to draw on 2 radii. You know that the radii have a length of 3, and these are isosceles triangles. The next thing we know is that the radius the radius meets the tangent at 90 degrees, and therefore this angle is 120. So we can work out the length of the side of the equilateral triangle using the cosine rule. Or I think there is a way of breaking down this triangle and then using normal trig, but I'm just going to use the cosine rule. So x squared is 3 squared plus 3 squared minus 2 times 3 times 3 times by cos of 120. And that is 18 minus 18 cos 120. Then cos 120 is minus a half. So this is 18 plus 18 over 2, which is 27. So therefore x squared is 27, and then x is square root of that, which is 3 root 3. So now we can work out the area of the triangle using half AB sine C, and that is, I think I'll write somewhere else because I'm running out of space here. A half multiplied by 3 root 3 multiplied by 3 root 3 multiplied by sine of 60, which is a half times 27 multiplied by root 3 over 2, which is 27 root 3 over 4. How do I know my exact trig values? I think I've just used them enough to I kind of just remember them, but if you have to draw the 30, 60, 90 triangle out, then you can do that. And in terms of cos of 120, I should probably explain how I worked out cos of 120. If you draw the graph, then it looks like that. So cos of 60 is 60 is a half. That's not very to scale, but it will do. Cos of 120, there's a symmetry, so this is minus a half. There's the working out. And the last bit is we have the area of the triangle and we have the area of the circle. So if I add A plus B plus B plus C, we have A plus 2B plus C. So the last step would be to subtract away the area of B. And the way I'm going to work out the area of B is I'm going to notice that B is equal to the area of this segment, or sector, not segment, sorry, minus the area of this triangle. So the area of the sector will be 120 divided by 360, because that's the angle that it makes, multiplied by pi r squared again, and that is 3 pi. And then the area of the triangle, again, I'm going to use half AB sine C to get a half times by 3 times by 3 times by sine of 120. And I will draw the sine graph, which is this. So there's a line of symmetry down x equals 90, so 60, 120, and therefore it will be root 3 over 2. And that gives 9 over 2 times by root 3 over 2, which is 9 root 3 over 4. So therefore our answer is the area of the circle, which was 9 pi, plus the area of the triangle, which is 27 root 3 over 4. And then B is the area of that sector minus the area of the obtuse triangle. And remember, we're subtracting B off. So we'll be subtracting off the area of the sector, which is 3 pi, minus the area of the obtuse triangle, which is 9 root 3 over 4. And this is equal to 6 pi minus 18 root 3 over 4, which is 6 pi minus 9 root 3 over 2. And hopefully I've not made a mistake in my algebra. It appears that I have. Oh yeah, it's minus minus, sorry. So that would be 36. And that would leave 9 and plus. Okay. So the answer is A. Okay, a graph sketching question. Which diagram represents a set of all points x, y satisfying that equation? So with graph sketching questions, I'm going to try and look at what the value of the graph is at particular points. So I'm going to see what happens when y equals 0. And that would give 0 is equal to x squared plus 2x. So 0 is x times by x plus 2. So x is equal to 0 or minus 2. So therefore the graph must go through the point 0, 0, and 0, minus 2, 0. So all of the graphs appear to go through the origin, and A does not go through minus 2, 0. Neither does D. So we've knocked out some of the options. The next thing I'm going to do is I'm going to see what happens when x is equal to 0. and that would give y squared minus 2y is equal to 0. So y minus 2 is equal to 0. So y equals 0 or y equals 2. So therefore the graph also goes through the points 0, 0, which we had before, and 0, positive 2 this time. So graph letter C does not go through the point 0, 2. And that leaves us with two options. So I'm going to just try and look at the differences between B and E. I'm going to notice that at the point on graph E, it appears that the graph is going through something around minus 1, 1. So I'm going to see what happens when I plug in y equals 1. And that gives 1 minus 2 is equal to x squared plus 2x. Therefore, x squared plus 2x plus 1 is equal to 0, and that can be factorized to x plus 1 all squared, so x is minus 1. So indeed the graph does go through minus 1, 1, which rules out option B, and therefore the answer is E. So with graph sketching questions, when they're multiple choice, I'd recommend just picking particular points and just experimenting with what values for coordinates you get, because usually you can rule out all of the other options. So positive integers m, n, and p satisfy that equation. What is the value of p? So I think this would just be some messy algebra. So the first thing I'm going to notice that n plus 1 over p is equal to np over p plus 1 over p, which is np plus 1 over p. So we get that 17 is 3m plus 3 divided by np plus 1 over p, and that is equal to, I'll put this in brackets, that is equal to 3m plus 3 multiplied by p over np plus 1, and that is 3m plus 3p all over np plus 1. And then I'm going to notice that I can factor out a 3 to give m plus p over np plus 1 is equal to 17. And then the next thing I'm going to notice is that p over np plus 1, that's a bottom heavy fraction. So this means that the fraction is between 0 and 1, which is because they're positive integers. So both the denominator and the numerator are positive. So together it's between 0 and 1. And if on this equation I divide both sides by 3, we get 17 over 3 is equal to m plus p over np plus 1. And what's the question asking for? Asking for the value of p. So this is equal to 5 plus 2/3, which is equal to m plus p over np plus 1. So therefore, m equals 5 and 2/3 equals p over np plus 1. Now, the second equation might seem a bit tricky because you might not know whether this fraction here is fully simplified, but there's something that you might be familiar with is the fact that if I have an integer, let's call it n, and another integer n plus 1, so we have two consecutive integers, then the highest common factor of these two numbers will always be 1. And that's because if you imagine that a number bigger than 1, let's say 2, was divisible by n, if 2 went into n, then 2 couldn't go into n plus 1 because the difference between multiples of 2 is bigger than 1. Could you just, like, does that make sense? Okay. And then similarly, we can also say that n and a multiple of n plus 1, so say like k n plus 1, by the same logic, these two also have a highest common factor of 1. So therefore we know that this fraction here is fully simplified, and that just gives that p is equal to 2, because p is just the numerator of the fraction. Okay, so now the questions are going to be getting a bit more hard. Two circles have their centers at the point 3, 4, and they touch the third circle, C3. The center of the third circle is the origin, and its radius is 2. So the first thing I'm going to do when I see this is I'm going to draw a diagram. So one of the circles, C3, is centered at the origin. Remember, you'll be allowed a compass, so you'll be able to draw circles. And this has a radius of 2. Now it's saying that two circles C1 and C2 have the same center and they touch circle C3. So you might be wondering how that is possible, but one of them will touch the circle internally and one of them will touch it externally. So the circle touching it externally will look something like this, and then the circle touching externally will look like that. I mean, the scale isn't that important for this. And this coordinate is 3, 4. So it's asking for the sum of the radii of circles C1 and C2. So the radius of C1 is equal to, if I call that radius R1, then this length is 2 because it's the radius of C3. And the distance between the center of the circle and the origin you can find using Pythagoras. So 3 minus 0 squared plus 4 minus 0 squared. And you might recognize this as a Pythagorean triple, which is just a set of 3 integers which satisfy Pythagoras' equation. And you might recognize that this is 5, or you could just calculate it. And therefore, R1 plus 2 is equal to 5, and R1 is equal to 3. And then the next thing is that R2 is the radius of the big circle. So R2 is equal to this length here plus this length here. So it's equal to 5 plus 2, which is 7. So the sum of the radii of the two circles is E, which is 10. The letters P, Q, R, S, and T represent different single-digit positive numbers, such that P minus Q is R and R minus T is S. So how many different values could T have? So the first thing I would do is I would just try and think and just play around with a few numbers for P, Q, R, and S. So I'm just going to see what happens when P is 1, Q is 2, R is 3, and S is 4. Remembering that they're different in different numbers, so we can't have them all equal to 1 or anything like that. And they're also single digit. So this would give, oh sorry, P minus Q is equal to R, so this isn't going to work. Let's say 3 and 1. So R is equal to 2, and then S is something. So, I mean, the way I would solve this is I would try and look at the extreme cases. So I would try and look at what's the maximum possible value of t I could have, and what's the minimum possible value of t I could have. So to get the maximum possible value of t, I'm going to want R to be as big as possible and S to be as small as possible. So for R to be big, we're going to have P big and Q small. So we have two big numbers, and the biggest single digit numbers are 8 and 9, and the smallest single digit numbers, which are positive, are 1 and 2. And we're going to have to look at different combinations of these small and big numbers. But, oh sorry, I keep forgetting that R is dependent on P and Q. So I'm going to take P and Q to be 9 and 1, and therefore R is equal to 8, and that leaves the next smallest number is 2. That would give T equals 6. So T equals 6 is the largest possible number that we can have. And now if I want to make T as small as possible, I'm going to want to have R and S as close together as possible. So I could just kind of try some numbers. So let's say I tried something like maybe make R equal to 2, or maybe because we're trying to minimize the value of T, we probably don't want to use up the numbers 1 and 2. So maybe I could try and make R equal to 4 and S equal to 3. What would happen in this case? Where we would get P minus Q is equal to 4. So that could be P equals 9 and Q is 5. And then that would lead to T equals 1. So that means that the minimum possible value of T is 1 and the maximum possible value of T is 6. Now, intuitively, it feels like there's no reason why T can't take any value in between 6 and 1. So what I'm going to do is I'm literally just going to try and search for possible values of P, Q, R, and S, which give all the values in between 6 and 1 for T. So if we want T is equal to 2, I could pick something like R is equal to 5, S is 3, and then that would be P is 9 and Q is 4. So T equals 2 works. For T equals 3, I could pick R is equal to 5 and S is equal to 2. And again, P is equal to 9 and Q is equal to 3. So T equals 3 is working. Where will this be posted on YouTube later? I'll send the link, don't worry, once I upload it. And then if we try and find t is equal to 4, we could have maybe what values we could have r is equal to 6, and yeah, r is equal to 6 and s is equal to 2, and then p would be equal to 9 and q would be equal to 3. And if you're wondering how I'm getting these numbers, I'm just trial and erroring in my head and seeing what's working and what's not working, because what I'm trying to do is find every value between 1 and 6, because intuitively it feels like every value between 1 and 6 should work. And so far it appears that the intuition is correct. And then finally t equals 5, which we can do with r is equal to 6, s is equal to 1, p is equal to 9, and q is equal to 3. So t equals 5 works. So in fact, we can find every number from 6 to 1 for t, and therefore the answer is 6. This one, the real numbers x and y satisfy the equation 4 to, I'm not going to read that all out, but they satisfy those two equations, and it's asking for the value of 5 to the power of x plus y. So this is kind of like a GCSE type of thing where you'd rewrite everything as the power of the same number. So for the first equation, I'm going to rewrite everything as powers of 2. So that would be 2 to the power of 2y is equal to 2 cubed times by 2 to the half, the x plus 2, which is equal to 2 to the minus 3 times by 2 to the minus a half x plus 2, which is 2 to the minus 3 minus a half x plus 2. So we get the equation by comparing the exponents that 2y is equal to minus 3 minus a half x plus 2, which can be further simplified to minus 3 minus a half x minus 1, which is minus a half x minus 4. And then for the second equation, I'm going to rewrite them as powers of 3. So 3 squared to the power of x multiplied by 3 to the power of y is equal to 3 to the 3 over 2. And then 3 to the 2x plus 3 to the y is 3 to the 3 over 2. And then 3 to the 2x plus y is equal to 3 to the 3 over 2. And therefore, again, comparing the exponents, that gives the equation 2x plus y is equal to 3 over 2. And now this is just like GCSE simultaneous equations. So I'm going to multiply this equation here by 2 to get 4x plus 2y is equal to 3. And then I'm going to substitute in this bit into here to get that 4x plus minus a half x minus 4 is equal to 3. And therefore 4x minus a half x minus 4 is equal to 3. And then 9 over 2x is equal to 7. Not 9 over 7 over 2. And therefore x is equal to 2. I'm just going to substitute this back in to find y, and we have that 4 plus y is 3 over 2. So y is 3 over 2 minus 4, which is minus 5 over 2. And now you just have to remember what the question is asking, which is 5 to the x plus y, which is equal to 5 to the power of 2 minus 5 over 2, which is 5 to the power of minus a half, which is 1 over root 5. So the answer is E. And now we're on to the final 5 questions, which should be the hardest. When written out in full, that number has 4,041 digits. What is the sum of the digits of the number? So this question looks quite intimidating when you first see it, but the way that I'm gonna look at the fact that I have something plus something all squared, and then I'm gonna notice that I can try and expand those brackets. So 10 to the 2020 plus 2020 squared is 10 to the 2020 squared plus 2020 times 10 to the 2020 plus 2020 times 10 to the 2020, and then plus 2020 all squared. And that's equal to 10 to the power of 4,040 plus 2 times by, I'm going to write this as 4,440 times by 10 to the 2020 plus 2020 all squared. And we've been told that this has 4,041 digits, which you can see from the fact that we have 10 to the power of 4,040, which would give us the 4,041 digits. So if you imagined doing like a column addition of, let's say we had like 1,000,000 plus maybe 4,000 plus 5, I'm just picking random numbers, we're going to notice that all the columns either contain all zeros, or they contain all zeros plus a number. So when we add it up, it's very easy to add up all the numbers. And in fact, what happens is that the sum of the digits of the final answer is equal to the sum of the digits of each number individually. And if we look at the numbers we've got here, we've got this 10 to the power of 4,040, which is the number which is 1 followed by 4,040 zeros. And we know that both of the other numbers in this sum aren't going to contribute anything to that 4,041th digit. So we can just calculate the value of the sum of the digits of this number, the sum of the digits of this number, and the sum of the digits for this number. Well, the first number that is going to have a digit sum of 1. The second number is going to have a digit sum of 4 plus 0 plus 4 plus 0, which is 8. And the last number I'm going to have to calculate. 2020, 2020, 0, 0, 0, 0, 0, 0, 4, 0, 4, 0, 0, 0, 0. Then 0, 0, 0, one more 0, I think. I've made this a bit messy. 1 second. Four, 0, 4. Okay. And that is 0, 0, 0. Oh, not 0. 4, 0, 8, 0, 4. Now I'm just going to find the sum of the digits of this number, which is 4 plus 8 plus 4, and that is 16. And therefore the sum of the digits of the final number should be 1 plus 8 plus 16, which is 25. 25 is my answer. A square with a perimeter of 4 centimeters can be cut into congruent right-angled triangles and congruent trapezia, as shown in the first diagram, in such a way that the 4 pieces can be arranged to form the rectangle in the second diagram. Okay, and what is the perimeter of this rectangle? So the square has a perimeter of 4, so each side is going to have a length of 1, so I'm going to label 1 for that side, and then I'm going to say that the shorter side length of the triangle is x. So this is 1 minus x. This is x. This is 1 minus x. And then if we look at this diagram here, the short side of the triangle is equal to the short side of the trapezium because they meet and form. They line up perfectly. So this will be x, and then that means that the long side of the trapezium is 1 minus x. And now we have some algebra, and we're going to try and solve for the value of x. Or in fact, the x's might cancel out when we plug them into the rectangle. So I'm going to label the lengths that we've got. 1 minus x, 1 minus x, 1, and 1 minus x. So we do need to find out what the value of x is to find out the is asking with the perimeter of the rectangle. Yes, the perimeter of the rectangle. So I think we're going to have to use Pythagoras for this. Yes, we can use. Can we use Pythagoras? Okay, so what I'm going to do is I'm going to let the length of the diagonal of the triangle be y, and then using Pythagoras on one of the this triangle here, we have that 1 squared plus x squared plus it is equal to y squared. But similarly, if I use Pythagoras on this triangle here, we're going to have to work out what the length of this bit here is. So I'm going to go on this bit here and draw that vertical line and this vertical line here. And because of the symmetry, the length of this bit here should be equal to x. So the length of this bit here is 1 minus 2x. So the length of this diagonal here, we can find using Pythagoras on x directly, because this length is 1 minus x. So we have the square root of 1 minus 2x squared plus 1 minus x squared. And that is, maybe this isn't the best approach to solving this. I think um, I think I'm going to have to think about this one for a few moments. Okay. I think I found a better way of doing this. So if we look at this triangle, oh, that's not very good. If we look at the triangle that's been circled here, this triangle is similar to this triangle here. So therefore, the ratio of this side is equal to the ratio of this side to this side. So therefore, 1 over x, or I'll write it as ratios first. 1 to x is equal to 1 plus 1 minus x to 1 minus x. 1 to x is equal to 2 minus x to 1 minus x. And then I'm going to rewrite this ratio as a fraction to get 1 over x is equal to 2 minus x all over 1 minus x. Now I can rearrange this, solve for x. So x is equal to 1 minus x over 2 minus x. X times by 2 minus x is 1 minus x. 2x minus x squared is 1 minus x. 0 is x squared minus 3x plus 1. And then I think I have to use the quadratic formula. So x is 3 plus, I don't need the minus because that will give a negative length. The square root of 9 minus 4 all over 2, which is 3 plus root 5 all over 2. And then finally, the question was asking for the perimeter. So the first thing I'm going to do is I'm going to find the perimeter of the rectangle in terms of x. So that would be 1 minus x. I'm going to cross each length off as I go. 1 minus x plus 1 plus 1 minus x plus 1 minus x plus 1. And that is equal to 6 minus 4x. And then substituting in the value of x we found here, that's going to give 6 minus 4 lots of 3 plus, oh sorry, it is, I was wrong when I said I can't use the minus in the quadratic formula, because in fact it isn't negative, and in fact we're supposed to be using the minus because we know that the length of x is less than 1. So this should be a minus. Minus 3 minus root 5 over 2. 6 minus 2 lots of 3 minus root 5. And that is 2 root 5. So I think that should be the answer. Yes. Okay, question number 23. A function f satisfies this equation for all x and y. And what is the value of f of 20 minus f of 2 all over f of 3? So when I look at this, what I'm going to try and do is I'm going to try and find f of 20 in terms of f of 3. And I'm also going to try and find f of 2 in terms of f of 3. And the way I'm going to do that is I'm going to, in the functional equation, a functional equation is just an equation in terms of a function. So this is a functional equation. So I'm going to substitute in y is 20 and x is 3. When will it be on YouTube? Probably later today or tomorrow, whenever I have time to upload it. So substituting in y equals 20 and x equals 3 gives 800 f of 3 is equal to 27 f of 20, and then rearranging that to make f of 20 the subject would give f of 20 is equal to 800 over 27 times f of 3. Similarly, to find f of 2 in terms of f of 3, I'm going to substitute in y equals 2. Can I explain why I substituted in those values? So when I looked at the problem, it's asking me to find the value of that fraction. So if I can have some constant times by f of 3 minus another constant times by f of 2, f of 3 again, all over f of 3, all the f of 3s are going to cancel. So it's going to be a constant minus a constant. So that's like the desired goal. So the way I'm going to find that constant is I'm going to have to find f of 20 in terms of f of 3, which is why I've plugged in y equals 20 and then x equals 3. Does that make sense? Okay, cool. So to find f of 2 in terms of f of 3, we're going to have y equals 2 and x equals 3. And that gives, oh, this is 8,000. But f of 3 is equal to 27 lots of f of 2. And then rearranging that to make f of 2 the subject is 8 over 27 times f of 3. So now I'm going to just substitute in all of these values into the equation because I've got it in the form that I've wanted. So 8,000 over 27 f of 3 minus 8 over 27 f of 3 all over f of 3, and the f of 3s are all going to cancel, and that just leaves 8,000 over 27 minus 8 over 27, which is 7,902 over 27, which I guess I'll calculate. That is 2. That leaves a remainder of 25. That'd be 9. With a remainder of 16. And then this is 6. So 296, which is D. Now we're on to the last two questions. In the diagram shown, M is the midpoint of PQ. The line PS bisects angle RQP. So this angle is equal to this angle and intersects RQ at S. The line ST is parallel to PR and intersects PQ at T. Okay, and the length of PQ is 12 and the length of MT is 1. So I'm going to just label those on 1 and 12. So we're trying to find the length of SQ. So because M is the midpoint of PQ, PM is going to have a length of 6 and MQ is going to have a length of 6. But because MT has a length of 1, that means that TQ has a length of 5. Then the next thing I'm going to notice is because ST is parallel to PR, that means that triangle STQ is similar to triangle RPQ because this line is parallel to this line. And that means all the interior angles should be equal to each other. And because of the similarity, we can find the scale factor which maps them to each other. So the scale factor is the length of TQ all over the length of PQ, which is 5/12. So the scale factor to go from triangle RPQ to STQ is 5/12. So that means if we can find out the length of RQ, that would be helpful. So at the moment, I'm not sure exactly how I'm going to progress through this question. So one thing I might do is try and find some angles. So I'm going to label this one X and this one X because they're equal, since we got told that they've been bisected. So using angles in a triangle add up to 100 and using angles in a triangle add up to 180. This angle here is 180 minus 120 minus 2x, which is 60 minus 2x. Then this angle here is going to be 180 minus x minus 60 minus 2x, which is 120 plus x. And then we're going to use the fact that the two triangles are similar to say that this angle, the angle over here, which is QST, is equal to angle QRP because of similarity. So that should be 60 minus 2x. And then we get that angle PST is equal to 180 minus angle RSP minus angle TSQ, because the angle's on a straight line adding up to 180. So this is equal to 180 minus 120 plus x minus 60 minus 2x, and that is equal to minus 180 minus 120 minus 60 is 0. So this is minus x plus 2x, which is just x. So if PST is equal to X and SPT is also equal to X, then we get that triangle PST is isosceles, and therefore the length of PT is equal to the length of TS, which actually I think means that this scale factor stuff is unnecessary, because I think we can just find the length of SQ directly using, what could we do it with? Cosine rule, I think. So the length of PT is PM plus MT, which is 6 plus 1, which is 7. So therefore the length of TS is 7. And then the final step would be use the cosine rule to find the length of SQ. So SQ squared plus TQ squared minus 2 times SQ times TQ cos of 120 is equal to TS squared. So now I'm going to substitute all the values that we know. So SQ squared plus 5 squared minus 2 SQ times 5 cos of 120 is minus a half, and that's equal to 7 squared. Then this will simplify down to SQ squared plus 5SQ is equal to 49 minus 25, which is 24. So SQ squared plus 5SQ minus 24 is 0. And then we can factorize this to SQ minus 8 SQ plus 3 is equal to 0. And because SQ is a length, it has to be positive. So SQ is, oh, sorry, the other way around. So SQ is 3. Yeah, plus 8, yeah. And now it's time for the last question. A regular m-gon and a regular n-gon and a regular p-gon share a vertex and pairwise share edges as shown in the diagram. What is the largest value of p? So the first thing is, what is an m-gon, an n-gon, and a p-gon? And it just means a polygon with m number of sides, or n number of sides, or p number of sides, just in case you wanted to know. And they're regular, so all of the interior angles are equal to each other. And the formula for the size of one of those interior angles is 180. For the m-gon, it will be m minus 2 over m. For the n-gon, it is n minus 2 over n. And for the p-gon, it is 180 times p minus 2 over p. And all of these angles are adding up to 360. Now I'm going to try and tidy this up. So the first thing I'm going to do is divide through by 180. So m minus 2 over m plus n minus 2 over n plus p minus 2 over p is equal to 2. And then I think I'm gonna put each of these fractions, like m minus 2 over m, I'm gonna rewrite them as m over m minus 2 over m, which is 1 over 1 minus 2 over m. So we'll get 1 minus 2 over m plus 1 minus 2 over n plus 1 minus 2 over p is equal to 2. And then this gives minus 2m minus 2 over m minus 2 over n minus 2 over p is equal to minus 1, and therefore 1 over m plus 1 over n plus 1 over p is equal to a half. So we're trying to maximize the value of p, which means we're therefore trying to minimize the value of 1 over p. So my instinct would just be to try some values of m and n and see what happens. So because we're looking at polygons, m and n must be at least equal to 3. So I'm just going to see what happens when m and n are equal to 3. And that gives that would give p as being negative, so that's not going to work. So from that, I'm going to have to observe that 1 over m plus 1 over n is less than half. So I'm just going to be trying some values that could potentially work. So the next smallest value, I can't pick a m is equal to 3 and n is equal to 4. I can't pick m is equal to 3 and n is equal to 5, because if I did, then I would get 1 over 3 plus 1 over 5, which is 8 over 15, which is greater than a half. I mean, yeah, another way of doing it would be to, I guess, just trial and error with the values of p. But if this doesn't lead anywhere, I'll try that. M equals 3 and n equals 6 also doesn't work. So because 1 over 3 plus 1 over 6 equal to a half, which is not less than a half. So m equals 3 and n equals 7. Let's see what happens here. 1 over 3 plus 1 over 7 is 10 over 21. So therefore p would be equal to a half minus 10 over 21, which is 1 over p, sorry, and this is 42 over 21 over 42 minus 20 over 42 is 1 over 42. So p is equal to 42 in this case. And I know that if I choose a larger, I'm going to see what happens if I choose larger values of n. If I choose a larger value of n, that's going to make the value of 1 over m plus 1 over n, this is going to get smaller, and therefore the value of 1 over p is going to get bigger. But we're trying to minimize the value of 1 over p, so I don't need to check larger values for n. So what I'm going to do now is I'm going to check the next largest value for m. So the next largest value for m would be 4. And again, I can't choose n equals 3 or n equals 4. So the smallest value of n I can pick is 5. So let's see what happens when we have m equals 4 and n equals 5. That is 9 over 20. So therefore a half minus 9 over 20 is 1 over 20. Well, if we have, well, p equals 42 is definitely bigger than p equals 20. So next I'm going to try m equals 4 and n equals 6. And that would give 1 over 4 plus 1 over 6 is equal to 5 over 12. And then a half minus 5 over. I see. We don't. Okay. I think I know what we can do. So I'm noticing that again, as I make n bigger, it's going to make the value of 1 over m plus 1 over n smaller, which is therefore going to make the value of 1 over p bigger, which is therefore going to make the value of p smaller. So as we keep increasing the value of m or increasing the value of n, we're always going to get smaller and smaller values of 1 over m plus 1 over n. It's going to give us bigger values of 1 over p, and then therefore that's going to give us smaller values of p. So in fact, the largest value of p is 42, which is kind of informal, but I think because there's a multiple choice exam, that's enough. Once you've got the answer, that's it. So that is the end of the paper. But before you leave, I do want to discuss what happens after senior maths challenge. So if you do well enough on the senior maths challenge, you might qualify for the senior kangaroo, or you might qualify for the British Maths Olympiad round 1. So the senior kangaroo is a bit like the senior maths challenge, but instead of being multiple choice, you have to give a numerical answer. But with the first round of the British Maths Olympiad, it's a very different type of exam. It's a proof exam. So you have to prove questions entirely, and you have to explain the steps that you're taking. So I've actually prepared some extra BMO1 types of questions, which are on the topic of rephrasing problems in a way that will make them easier to solve, which is, I think, one like very important thing with problem solving. So I put in brackets bijections, and a bijection, if you're familiar with a one-to-one function, that's the same thing as a bijection. So all a bijection is transforming one problem into another identical problem. More formally, it's a function between two sets of equal size, but you can think of it as going from one problem, which is phrased in one way, to going to another problem, to going to the same problem phrased in a different way. So it's quite commonly used in combinatorics, which is a study of arrangements and counting. So this is the first problem I want to talk about, which is a city has roads running from north to south and streets running from east to west. Every road meets every street at exactly one point. I start at the point of intersection of the first road and the second street, and I want to arrive at the intersection of the fifth road and the ninth street. How many paths of shortest length can I take? So with this, I'm gonna try and draw a diagram of some sort. So we have roads running from north to south, like this. And then we have streets going across like this. So it says that I start at the first road and the second street. So the first road and second street is here, and I want to end up at the 5th road and the 9th street. So 1, 2, 3, 4, 5, 2, 3. Oh, sorry, I'm counting the wrong way around, but 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5. So I want to arrive here. And we want the paths to be of shortest length. So these are a bit like coordinates. So I can write this as, if we imagine the origin was, but it wouldn't, if we imagine the origin to be somewhere around here, and if we imagine that all the coordinates are still positive, just for the convenience of the question, this would be the coordinate of 1, 2, and this would be the coordinate of 5, 9. So a shortest path will consist of moving right 4 times, or east 4 times, and south by 7 times. Because if we moved in any other direction, we wouldn't have a path of the shortest length anymore. So we've kind of converted the problem from thinking about finding paths from one point to another to now choosing east 4 times and south 7 times. So I'm going to encode the move east as E and the move south as S. So what we're actually doing to find the path between our start and end points is we're trying to find a sequence of E's and S's containing 4 E's and 7 S's. So for example, E, E, S, 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 E, S, S, E, S, S. That would look like this, then 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 this. So what we've got is, given a sequence of moves, which are easts and souths moves, we can get from the start point to the end point as a path. So some of you or most of you will be familiar with the notation of n choose k, but for those of you who aren't familiar with that, what n choose k, this kind of vector looking thing is it's the number of ways of choosing k objects from n objects. So if I, for example, had 4 and I'm choosing 2 of them, so if I had one object here, one object, I'll make them different shapes. It's asking how many ways from these 4 objects can I choose 2 of them. So we're going to have 4 choices for the first one, and then 3 choices for the second object. But what's happened is I've overcounted, choosing one object then the other one, or the other one and then the first one. So I need to divide through by 2, or in general I've divided through by 2 factorial. And then this can be written as 4 times 3 times 2 times 1 all over 2 factorial times 2 times 1. So these would have cancelled. And that is 4 factorial over 2 factorial times 2 factorial, which means that the number of ways of choosing 2 objects from 4 is this thing here. And in general, if you apply this for n objects and we're choosing k of them, this ends up being n factorial over k factorial times n minus k factorial. Okay, so with this problem, what we're doing is we have 11 instructions in total, and we're choosing 4 of them to be east. So what we're trying to find is the value of 11 choose 4. And I'm not actually going to calculate what 11 factorial divided by 4 factorial times 7 factorial is, but that would be the answer to the problem of how many paths of shortest length are there from the second road in the first street to the 5th road and the 9th street. So that's kind of like a way of rephrasing a problem in a different form. So with question number 2 here, it's again, I'm going to be rephrasing this problem. So how many solutions are there to the equation a plus b plus c plus d is equal to 10, where a, b, c, and d are all positive integers? So you might be familiar with something called a partition. So a partition of a number is writing that number as the sum of numbers smaller than it, which are all positive. And in the partition, the order that the numbers appear doesn't matter. But here, because we've given the variables names, we've given them A, B, C, and D, the order that they appear does matter. So it's actually more like a composition, which is an ordered partition. So the question is asking how many compositions are there of 10 which contain 4 numbers. So again, I'm going to rephrase this as a sequence of moves. So if we have 1, we can write 10 as 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is equal to 10. And if I place a barrier here and a barrier here and say a barrier here, I would get 3, 2, 3, and 2. So what's happening is I'm starting off with 1 plus 1 all the way 10 times, and I'm placing these barriers in between to try and separate these ones into 4 numbers. So again, this is like performing moves. So if we have 10 ones and we have 3 barriers. So in total, we have 13 objects, and we're choosing 3 of them to be barriers. So that means that this problem here, how many solutions are there to that equation, positive integers, that's the equivalent to asking how many ways are there of placing 3 barriers in between 10 equivalent symbols, which I think is quite cool, that you can reduce a problem about an equation into choosing objects, basically. And you can apply this kind of logic to many different problems. I think these problems are more on the easier side, but I have got two more problems. One is on the harder side of the same topic of choosing moves, and then the other one's a kind of similar rephrasing of a problem, but for algebra rather than for combinatorics. And then there is also a challenge question for people who are interested. So with question 3, how many different subsets of 1, 2, all the way up until 12 contain exactly 4 numbers exist such that no 2 of the numbers in the subset are consecutive? So this wording, if you're not familiar with Olympiad type problems, it might be a bit confusing. So a subset is just a group of numbers which are all in the original set. Yeah, that's what a subset is. and a subset containing 4 numbers will have 4 from the original set. So for example, 1, 3, 7, and 9. This is a subset of 1, 2, all the way up until 12. And the question is asking how many contain exactly 4 numbers such that no 2 numbers are consecutive. So before, when we were trying to encode this into choosing some moves, we could kind of, the moves that we were trying to choose, they kind of came naturally. With this problem, categorizing a move is a bit more tricky. But the way that you can imagine it is, if I choose a number x, then I cannot choose the number x plus 1. So if I choose x, then I can't choose x plus 1. So you can think of it like, if you had 12 soldiers and we're choosing 4 soldiers, and if I choose a soldier, then that soldier must kill the soldier next to it. So if I choose the second soldier, then the second soldier must kill the third soldier. And there's one thing that might be a bit confusing, which is, when I choose 2, why am I not killing the soldiers on both sides of me? But if we imagine systematically going from the start of this line of soldiers, if we go from the start and we pick our first soldier, we know that we're not going to pick any soldiers before him or her, because we've decided that they're the first soldier. So we don't actually have to kill the soldier before us. So in the same way, when we're talking about this set of numbers, once we choose one of the numbers, we're going to kill the one next to it. And then the next thing you might notice is, well, what happens if we choose the number 12? Well, if we choose the number 12, then what's the number 12 going to kill? Because the thing about this logic is that the killing argument has to apply to every number in the same way. So the way that you can get around this is you can imagine if that this set of 1, 2, all the way up until 12 actually goes up until 13. And the reason is, what we're doing when we're killing the person next to it is we're actually grouping all of the numbers into like blocks of 2. So with this grouping, like a move is, technically we're choosing a box, and then we're choosing exactly one of the numbers from that box. So if we look at how many boxes there are, well, we have 1, 2, 2 and 3, 3 and 4, all the way up until 12 and 13. And these boxes, we always choose the number on the left of the box, because the number on the left is like the soldier, and then the number on the right is like the person we've killed. So how many of and the thing is, the number 13 can never be on the left. So it's either not included or it's been killed. So we never actually choose the number 13, which is why it's like a ghost element of the set. So there are 12 boxes in total, and we're choosing 4 of them. So the answer ends up being 12 choose 4 for this problem. Oh wait, have I made a mistake? Give me a second. Give me a second to think about it. Oh, I think I know it's gone wrong. I wrote the problem down wrong at the start. It should be up to 13 because it doesn't work. It doesn't work nicely with 12, I think. Hmm. Oh wait, no. No, it does work with 12. I know I've done wrong. Okay. So what is I'm gonna write um 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So remember I was talking about the blocks. So I'm gonna put four pairs into blocks. Just I'm just gonna pick random blocks. Let's say something like this. And then the remaining numbers would go in their own blocks, like this. So the total number of blocks is always going to be 3, 4, 5, 6, 7, 8, 9. So it's always going to be 9 blocks. And again, the thing I said about the fact that 13 is either killed or 13 is not included, it still stays true. So the answer ends up being 9, choose 4, because 4 of them are big blocks. That was kind of a mess, but yeah. So the final problem is an inequality that I thought was quite interesting. So it says the area of a triangle can be written using this formula, which is called Heron's formula. And it's where A, B, and C are the lengths of the sides of a triangle, and S is known as a semi-perimeter, which is half of the perimeter. And I'm going to use this to prove the following inequality. So the thing that I'm doing is I'm converting a problem about an algebraic inequality into a problem about like geometry, like looking at the area of a triangle. So the first thing I'm going to have to notice is that not all triplets of numbers A, B, and C will always form a triangle. And there's this thing called the triangle inequality, which says that three numbers A, B, and C will form a triangle if A plus B is greater than C, A plus C is greater than B, and B plus C is greater than A. And the reason is, if I draw a triangle here, the length of this side plus the length of this side must be greater than the length of the third side, otherwise they wouldn't be able to form a triangle. So what we're going to have to do is we're going to have to split the problem into cases, where one case where the triangle inequality is satisfied, and another case where the triangle inequality is not satisfied. So the first case I'm going to deal with is what happens when our three numbers A, B, and C do satisfy the triangle inequality. So when this is true, then we can use the fact that the area of a triangle is also equal to half AB sine C, and the area is equal to the square root of the semi-perimeter S times by S minus A, S minus B, and S minus C. And then that means that A squared is equal to S times by S minus A times by S minus B times by S minus C. And I'm going to substitute in that S is equal to A plus B plus C over 2. So we get a squared is equal to a plus b plus c over 2 multiplied by b plus c minus a all over 2 multiplied by a plus c minus b over 2 multiplied by a plus b minus c over 2. And then this is all equal to 1 over 16 lots of a plus b plus c times by b plus c plus a times by a plus c minus b times by a plus b minus c. Okay, so all of these steps might seem a bit arbitrary, but if we relook at the question, this bit here looks a lot like the equation that I've got here, and that's for good reason, because we're going to use the fact that this is equal to the area of a triangle in a different form, which is this bit here. So a squared is also equal to 1 over 4 a squared b squared sine squared c. So therefore we get that 1 over 4 a squared b squared sine squared c is equal to 1 over 16 times a plus b plus c times b plus c minus a times a plus c minus b times a plus b minus c. So you might get stuck here and not know what to do, but what I'm going to do is use the fact that if I draw a sine graph, then the value of sine is always between 1 and -1. So therefore the value of sine squared is always between 0 and 1. And that implies that a quarter a squared b squared is greater than or equal to 16th of a plus b plus c. B plus c minus a, and then a plus c minus b, a plus b minus c. And then timesing both sides by 16 gives 4a squared b squared is greater than or equal to a plus b plus c, b plus c minus a plus c minus b, a plus b minus c. And now I'm going to go back and look at what the question actually wanted us to prove, and it's to prove that it's greater than or equal to this thing here. So I'm going to notice that a squared plus b squared all squared is equal to a to the power of 4 plus 2a squared b squared plus b to the power of 4. And remember, when you square something, it's always greater than or equal to 0. So therefore, a to the 4 plus b to the 4 is greater than or equal to 2a squared b squared. So then the final step would be to notice that 4a squared plus 4a squared b squared is equal to 2a squared b squared plus 2a squared b squared. but then in fact a to the 4 plus b to the 4 plus 2a squared b squared is greater than or equal to 2a squared b squared plus 2a squared b squared, and therefore a squared plus b squared all squared is greater than or equal to 4a squared b squared. So we get the final bit of the inequality which we were looking for, and we've done this case. So that's the hard bit of the problem, and then the last bit is to see, well, what happens when one of the triangle inequalities isn't satisfied. So we're going to say without loss of generality that A is greater than or equal to B, is greater than or equal to C. So we can suppose that B plus C is less than or equal to A. Well, that would imply that this bit here is negative, but then if we look at this bit here, it's positive. So the positive thing has to be greater than or equal to the negative thing. So that's what happens when one of the triangle inequalities is not satisfied. And then if two of them aren't satisfied, so let's say that A plus C is less than or equal to B, then um, um, then we get that A squared plus B squared is greater than or equal to B plus C squared plus A plus C squared or squared, and then and then that is, oh, I see what happens. There's going to be a contradiction. So that is B squared plus 2BC plus C squared plus A squared plus 2AC plus C squared all squared is greater than or equal to A squared plus B squared plus 2BC plus 2AC plus A squared plus C squared all squared. But then this bit here is positive. So this bit here is also positive. So something positive plus something positive all squared can't be greater than or equal. This thing is physically impossible for this thing to be greater than or equal to that thing, which is a contradiction, which means that this case could never have happened in the first place. And the last observation which completes the problem is that all three of the inequalities can not be not satisfied. And that completes the problem. So I think this has gone on for quite a while, but I hope it was interesting, and I hope that especially the senior math challenge walkthrough, I hope that was helpful. And here is a challenge problem which I'll send into the math discussion later. But if you want to take a screenshot of it now, you can. And I think I'll end the lecture here.